Okay, everybody, we're going to get started. Just as a reminder, if you're still having issues with the randomness, please look at the examples that we covered this morning. I think they're very insightful for like what you should be doing, but I also still had quite a few people stop by office hours today with the exact same problems that we walked through. So make sure that you're following the form that's given in the example as the good way to do it. Are there any questions before we get started? Yeah. So the question is, when you try to create a variable using the default constructor, do you still use the parentheses? The answer would be no. So if I wanted to create another number, like over here, and just like name num4, num4 is now initialized using the default constructor. So he'll have a 0 for his real part and a 0 for his imaginary part. Any other questions? Okay, then we will pick up from where we left off at. So one thing you might have a question about is how should you figure out whether something should be public or private? Public are the things that you want people to be able to do when they interact with your class. How do you want people to be able to use it? Those functions that people should be using, make public. Private are like implementation details, things that the user shouldn't have to mess with, right? And they shouldn't be using. Generally, these are going to be like your members, and there may also end up being some other methods as well that you would want to make private. So just because they get something done, but no one on the outside needs to use them. An example of this is like, think about your car, right? Your car has a public interface. Do you know what it is? Like the steering wheel, right? And like the ignition for you to put the key in, and the pedals, right? The gas and the brake, as well as like all the radios and AC and all those gadgets, right? But do you need to know like internally like how your AC is working and what it does when you press the thermostat down or thermostat up? No, you just need that up-down control. So those internal details would be the private implementation details of how to raise or lower the temperature inside your car. You just need the interface, the up and down button on the thermostat. Does that make sense? Or like when you press the gas pedal, do you really care how it makes your car go faster? No, and people don't need to know. They just need to know, like, when you press the gas pedal, I just need to know how much is it being pressed to know how fast to accelerate. The other thing that you might see, especially if you come from a Java background, are getters and setters. What getters do is they get the values of your member variables that you want people to be able to access, and setters allow you to set those values. This is really useful because it gives you a lot more control over how users interact with these members that you allow them to use than just making them public and allowing them to set them to be whatever they wanted. For example, like you might make like a line segment class, right? And a line segment class might have a length. And you might want the user to be able to get that line's length, right? You might want the user to be able to set that line's length. But it probably doesn't make sense for the user to be able to set that line's length to be like negative number, right? You couldn't have a line that's like -5 units long, right? The line always has to be a positive length. So what you might do is you might provide a setter that takes in the value that you want to set the line's length to, but you check it first. You're like, oh, hey, is this line's length actually something valid, some number greater than 0? Then you allow it to be set to that. Otherwise, you say no. So I'm going to recommend that when you write your code, if you want users to be able to interact with your variables, you do use getters and setters. It's going to give you much more control. And if things need to change behind the scenes about how you calculate some value, then you only have to change the internal details of that function. You don't have to go change your entire API and break people's usages on it. The downside for doing this is you have to write more code. But the very nice thing is that the IDE can generate getters and setters for you. So if we go back to our complex number class, what we can do over here in complexnumber.h is we can click down here and we can say code generate, and you'd be like getters and setters. And then you're like, well, what do I want for my getter? What do I want getters and setters for? And there's also just a version for getters and a version for setters. and you do real and imaginary, because it's probably convenient for who's ever working with our class to be able to both read these values and set these values to something different directly, right? So the getter just returns the real, and the setter just changes it to be whatever the user passed in. So now what we might do is everywhere we just used real and imaginary before, we might do this to get real and get imaginary. And then this one we could do, if we really wanted to be good people, we might do something as like set real as to get real, like negative. But you can see that sometimes some of these things can become like a bit verbose over just writing real equals negative real. But it does give you a bit more control over what's going to be happening in that. Any questions? Some of these things might be like a bit more overkill to do for small examples like this. Okay, you've also seen that this pointer, right? Its name is this, so sometimes it's confusing to talk about, but it's the equivalent to self in Python. This is useful if you need to disambiguate between a member variable and a local variable, as we've seen before. If we have something named imaginary as an argument and we want to talk about our imaginary member, img, we can say this arrow img to make sure that we're really talking about ours and not the argument. It's also useful when you need to call yourself as a parameter, which you've already seen before when you passed in star this to some functions. And it's useful if you ever need to return a pointer to yourself. And we'll probably talk about pointers next week. Some final things is with static variables, or with normal member variables, every instance of a class has their own version of that member variable. So every complex number that we create has its own real member, has its own imaginary member, right? Just like every vector has its own elements that are inside of it, or every vector has its own length. Each have their own version, or each have their own instance of that member variable. But sometimes you may have it where you may only want a single instance of that variable, and you want that thing shared across every single instance of that class. If you do, you declare that variable as being static. Then everybody has it, and there's only a single instance. This is really useful if you're defining maybe some constant values that people need to refer to. So you can have a const static variable so that people don't have to create a new instance of that variable every single time. You can also use it sometimes to keep track of how many instances of a variable exist, or maybe use it to assign a unique ID to a class. I'll show you examples of this in one moment. Some other things is if you declare a static member variable that is not const, it only counts as a declaration. You still have to give it a definition. That definition should be given exactly a single time. And probably a good place to do this is in the corresponding .cpp file. You do not need an instance of the class to access the static member of the class. For example, you can just do static, the name of the class, : variable name. This is because, again, this static member variable is not a part of the class. Everybody shares it. So again, we'll see an example in a minute. You can also declare a function as being static. That means it doesn't. You do not need you do not need an instance of the class to operate for that function, which means you don't have access to this or any member objects. You can also only call non-static other member functions or any other publicly available or any other global functions in those classes, but you couldn't call like a member function directly. So I'll show you some examples of this in a second. So over here, I've created an instance of a class. Its name is counted class. And all it does is keep track of how many instances of this class were created. So I have some static methods and static members. So over here I have this static integer whose name is some number. It's const, so I can give its value in the declaration as well. And this is just some constant value that every instance of the class shares, but there's only one copy of it. So sometimes you have like some key values that you want to give like names to. This is a great way to do it. I also have another static method that's going to print out the number of active instances. So when you call this function, I'll tell you how many instances of that class, this counted class, are alive right now. And we have two other static members, the number of active instances and the number of instances that were created. And then every instance of the class has an ID. So again, remember these two variables, they are shared across all instances of that class, right? Each class doesn't have its own num active instances or num instances created, but every instance of the class does have its own ID. So if we pop over here to countedClass.cpp, you can see at the beginning, this is where I made the definitions of those static members. So the number of active instances was equal to 0, and the number of instances created is equal to 0. Notice I had to say, counted class : to say that they are indeed inside counted class, and I had to respecify their types again as int. So these two lines, 7 and 8, where I'm actually creating the space for the variables and initially assigning them to be 0. Any questions here? Correct. If you change a static member variable inside one instance of that class, all the other instances of that class see that change because there's that one variable that they all share, instead of them each having their own variable. Yeah. So the question is, how is it different from global variables? It's nested inside the class, but they are somewhat similar. I can also put some protection levels on them, like private, where I couldn't do that on a global variable. Any other questions? Yeah. Yes, global variables are any variables defined outside of classes or functions. So hopefully you've read your assignment carefully, and it says no global variables in it. If you do create global variables inside of your answer, you will lose points. The TAs will come back through manually later and deduct points for submissions that do have global variables. And again, a global variable would be any variable declared outside of the class or outside of a function. If you have anything there, you'll lose points. Yeah.
Top, fine, and then number.
So if I said like int x equals 5.
It says like fine, like say.
Oh, pound defines?
Pound define.
Those are basically global variables. Yes. So if the variable is declared inside of main, it's inside of a function, main, so it's not global. So over here I have my constructor for counted class, and what I'm going to make my ID be equal to is the number of instances of that class that I've created, right? So my ID gets set to be that. And then over here you can see that I needed to do some additional pieces of code to make sure that everything else works correctly. So because I've created one more instance of the class, there's one more active instance, and the number of instances of the class that I've created of this class have increased by 1. I also print out that I created this person, and I said, how many active versions of that class are there? For the destructor, right, I'm deleting that class, so the number of active instances goes down by 1. We delete that counted class, whoever had this ID, and then we print out how many active instances there are. And then in printing out the number of active instances, it says there are now blank active instances of this class alive. So maybe these lines over here would probably be better replaced with something like counted class, : print num active instances. But notice that inside this function, because this function we declared as being static earlier, I can't say something like ID, because this is not called on a particular instance of that class. So ID doesn't exist, right? Invalid use of member ID in static member function. I don't have an instance of this class to operate on. I also can't say this because, again, I didn't receive an instance of this class to operate on. So this also does not exist. You can, though, if you want to, instead of, as you saw before, with doing the pounded class : print num active instances, you can, as somewhat of a shortcut, say this, print num active instances. It also works. But even though I did this arrow, it's not actually going to receive this as an argument. It's just a way of being able to reference this function without having to specify the name of the class. Or even if I just did print num active instances, it would also know to call this function down here. But again, no members are being passed this function, so no this, no ID. Over here in main, some things that you can see is if you want to access that member, you can say counted class : some number to access that static member. You can also do, again, like C1 dot some number, an instance of that class dot the static member to be able to access it as well. So over here, I create some elements. I create 10 instances of the counted class. Then I delete some of them. Then I print out how many active instances there are. And again, you can call it on a member of the class. That's fine. Or again, you can call it directly. Counted class : print num active instances. We go ahead and rerun this. You'll see, like, I'll create lots of instances of the class and then print some stuff out, and then things will go away. So our random number is 12. That's from back here. And every time I create an instance of the class, like C1 or C2 or C3, notice that I created one more instance of that class. And it's printing out its ID each time. So we make lots of them. We delete some of them. We print out how many are alive, and then things get deleted, and we print out a lot more of them all dying. Yeah? No, in the constructors, this part happens first, initializer list, and then the body gets run. Yes, and then 1, then 2, then 3. If we go back up here at the beginning, you can see that we print out his ID over here, and it's ID of 0. Any other questions? So you probably won't find a ton of usages for static members or static member methods in this class. I just want you to let you know that they exist. So if it makes sense for that problem to do it, you can use it. So the next thing that I want to do is, how many of you guys have played TicTacToe before? Crosses and knots, X's and O's. I don't know any other names for it. Well, we're going to create TicTacToe in class, and you guys are going to help me write it. And we're going to do it in an object-oriented programming style. So we're going to create like a TicTacToe game, and things are going to be made up of it, or inside of it. So let's get this happening. So one thing that we're going to try to really practice when we're doing this example is doing top-down programming. And this is something that I still always struggle to remember when I'm doing it, but hopefully seeing some examples here will help you use it in your own life. So the first thing that we want to think about is, well, what do we want to do with our program? We want to play tic-tac-toe. So if we think about it at a very broad level, what do you have to do before you play tic-tac-toe? Yeah, you got to like make a game of tic-tac-toe, and then after you make it, what do? You play it, right? So if we think about what we just said, we need to, one, create an instance of a game of tic-tac-toe, right? And then afterwards, we want to play it. Is there anything else we want to do? Don't get too low, right? This is top down. You want to think as like general and as broad as possible. We may potentially want to play it again, but if we have the ability to play the game, right, we can just call the function again, right? So notice we wanted to create a game of tic-tac-toe. So I want a game of tic-tac-toe. Maybe it's called game. And then after I create my game, what do I want to do? I want to play it. So game.play. Perfect, I'm done. Right? And in a lot of ways you're like, that seems kind of ridiculous, but that's what I want to accomplish. But now that we know what we want to do from the outside, and you really want to focus on what do I want to be able to do for my class from the outside, we can figure out what the heck do we need to do on the inside to make that happen. Does this make sense? And I know most people are like, what the heck, how is game.play going to work? Is this magic? No, we'll put the details in there later on, but we'll figure out what needs to be there later. So we'll create a new instance of the class called TicTacToe. And we know that for one of our public members, we need to have a play. Great. We may also want to potentially at this time think about like what constructors do we want to put in there, if any. Do you guys think of anything that you might want to if you wanted to make a more generalized tic-tac-toe game? Yeah. Yeah, like the size of the board. So we might have something over here like tic-tac-toe, and we might have it where we have one that takes one argument. That's going to be like the int, the board size. And then we might have another one that takes in nothing. And in the one that takes nothing, it might default to your standard game of a 3x3. Does that make sense? And then we're also going to need a destructor that pretty much does nothing. You can say this is equals default, do nothing. Okay, so we'll ignore setting up for right now, and we'll focus on playing the game. So how do you play a game of tic-tac-toe? So let's assume that player one always goes first, right? We could have it do a random coin flip if you want, but for right now we'll have it, we'll figure out that the first player might go first. But if we want to make it more generalized later on, you might have something like get starting player. And this is going to need to return something or do something. Right? And we can figure out what actually needs to happen. And maybe this is not like get starting player, but maybe it's like determine starting player. And so you could, at the very beginning, like, determine who the starting player is going to be. Sure. So you picked who goes first. Yeah. So we probably want to show the state of the game, right? Which for us is going to be like the board. After we show the state of the game, what should we do? Okay, who wants to play tic-tac-toe with me? Come on up. I promise I'll lose. Yeah, come on. So one of the things that we've already assumed preemptively is that we've already created the board, which is what's going to happen on our constructors, right? So now we're going to determine, right? We determine who's going to be first. Do you want to go first? Your name is Dominic. Do you want to go first or do you want to go second? First. So we ran our determine starting player. So Dominic is going to go first. And we now show him, this is what your board looks like. So we showed him the game state. Now what do you do, Dominic?
I mark my space.
Sure, right? So, right, so Dominic got his move in his head, right? And then after he got his move, what did he do? Put it on the board, right? So he got a move, and then we made the move. Right? Now, after Dominic has made his move, what's going to happen? It's going to be my turn, right? And what am I going to do? Oh, look, I can see the state of my game, right? I saw it. And then I'm going to figure out some move, right? And then I'm going to make my move. Now what happens next? It's going to switch back to Dominic, right? And then what's Dominic going to do? We're going to show him the game, right? And then he's going to figure out his move. And then he's going to make his move, right? Then, after this, right, it's going to switch back to me. Just give 1 second. And, you know, I'm going to get my move, and I'm going to make my move, right? Then it's going to switch back to Dominic. And then Dominic, he sees the game, right? It's pretty, it's amazing. He makes his move, right? And then we figured out that, you know, here we can see, should I go now? No, why? Because somebody won, right? But even if I didn't win, right, we could have potentially tied if I was a lot better at this game, right? But if we tied, we still would have stopped, right? So we keep playing the game until when? Until it's over. Right? That's how long you play any game. You keep playing it until it's over. But what being over means is different for each type of game. Thank you very much, Dominic. Give him a round of applause for being a very accomplished tic-tac-toe player. So one of the things that we needed to do was we needed to, you know, switch the turn, right? Switch whose turn it is. And we wanted to keep doing this, right, while the game was still going, right? So while not is game over, right? So while the game isn't over, we need to keep doing all this stuff, right? And then afterwards, right, after we, you know, finished completing the game, right, we had to, like, you know, declare the results. Does this make sense? Right? Like, you know, you won or you tied or whatever else happened. So we cool here? So some things we might want to do before we get too much into this is also like figure out like what is our game made up of. So what is a game of tic-tac-toe made up of? Right? So we have some players, right? There's a board. So I might have a board called board. And then I might also, if I'm being a little bit lazy, I might have a TD : vector of player called players, right? Or again, if we wanted to, we could have player 1 and player 2 as two separate elements, but making it be a vector is going to be just a little bit easier later on. Does that make sense? Right? But now we have to go figure out how to do these other things too, like how is a board going to be represented and how are the players going to be represented. But for right now, I'll just create two kind of like shell classes for us so that it stops complaining. We'll have a board, and we will have a player class. And then back here in TicTacToe.h, in addition to including vector, I can include player, and I can include a board. And then these complaints down here will go away. One other thing that we might do is decide to put our code inside of a namespace. So we might have like a namespace, and it might be called TicTacToe game. And now this stuff is all inside a namespace. And we'll make sure to put the other elements of our project also in this namespace as well. And back here in TicTacToe.cpp, it's going to be some complaining at me. : And And then over here in board.h, you'll be inside of the TicTacToe game as well. And the player will also be inside that same namespace as well. Oops. I think I forgot to say namespace on both of those. Okay. So now everybody's enclosed inside a namespace to help prevent name pollution if you decide to use this somewhere else. Okay. So if we pop back over into TicTacToe.cpp, maybe we might say something. So you want to show the game state, right? And so what does showing the game state involve? What? Yeah, so what would you want to show to the player each turn? Yeah. Yeah. Yeah, so we just want to show the board, right? So this line of code over here might be something like board.display. Great. Right? Got that piece of code taken care of. So the next thing that we need to do is get a move. And so how can we get a move? Well, we might need a get move function, right? And a move might need to be a new class as well. So we might have, say, something like move equals get valid move. Perfect. Then we might have it for our next step. We might need to actually make this move. So we might say something like, do you want the move to make itself, or do you want to make the move on the game? So you could do something like this, like move.make, and you could make it on yourself on this game, or whatever else might need to happen. Technically, you'd only need to pass in the board, right? That would work. So we can do like move.make, right? And then something, or we could do make move, and then you pass in the move. Which one do you like better? Option number 1, move.make. Option number 2, make move, move. We can try and do both versions, just so you can see it being done 2 different ways. So for right now, we'll just start with move.make. Then I need to change the turn. So I call change turn. And then I need to declare the results. So I declare results. And you guys might be like, what the hell are you doing? This is very stupid. Nothing's happening here, right? But what I'm doing is I'm breaking my problem down into smaller problems, right? Each of these smaller problems should theoretically be easier to solve than the big problem that composes them all. So by breaking it down, like if you read this right here, doesn't it seem very similar to exactly what we said to do? Would you have any questions what involves, like if you saw this, would you be confused at all as to what's happening? I mean, you might be like, well, how does this magic stuff happen, right? What's going on behind the scenes in all these functions to make it do this stuff? But if someone said, like, this is how you play a game of tic-tac-toe, you'd kind of be like, yeah, duh, thanks, right? And hopefully when you're writing your code, most of the code that you write is, yeah, duh, thanks kind of code, because that means it's really easy to understand, and people won't have a hard time figuring out what the heck it is that you were trying to do. Unfortunately, not all code can be yeah, duck code. Right? But this is going to be a lot better than like writing a function that involves like 300 lines of code and then trying to piece apart like what does playing a game mean if it's all stuck together as one element. Does that make sense? So this is like doing that top-down programming. So we've now come up with a couple more problems. What do you want to do first? What? So we might want to build the board, so we might want to start back over here with our constructors. Sometimes it's hard. So like one thing that I found when I've been doing this is that if I start like straight off with like initializing all of my members and saying this needs to be that and this thing needs to be this other thing and all this stuff needs to be set up as XYZ, And then I realized that, oh, dang, I now need to do something else. I have to go back and like rewrite a portion of my code or do things a little bit differently, because it didn't start with the high-level overview of what I wanted to have happen first. So over here, though, we might have to do something. One other thing that we might want to do is, before we kind of like do this, you might want to call like setup game. But that might need to be done outside. Do you want setup to be done every time you play the game? Do you want it to be a separate function? Or do you want it to be a done inside the construction of the class? So inside the construction of the class, every time we play the game, we set it up. The user must remember to call setup game before they call play game. I mean, that makes a bigger onus on them, right? But depends. Where did this thing go? Oh, it's down here. So the first thing that we probably would need to do is initialize the board. So I might say, hey, board, go build yourself board size big, right? And then I also need to go and initialize my players. So what would we want to do to initialize our players? Right? Again, things kind of like get stuck down to a little bit. One thing what we might want from their players is their names, right? And we might also allow the user to choose a symbol for their that they want to play, right? Like, do you want to be X's or O's, or do you want to be J's and K's, or whatever you feel like? So what we might do over here is then create a here. We might say, you know, players, and I want to create 2 players from a game. Thanks. Great, we're done. Yes. So remember the stuff that happens. The question is, what happens in the after the colon versus what happens inside the curly brackets? Remember that in between here and here, your instance of your game is still being built. So we're actually still building up the board and the players. But when you get in here, the board and the players have already been created, right? Those things exist. So it's creating and initializing. Everything's already been created and initialized, and there's other stuff I need to do. Yeah. So the vast majority of your variables can be initialized in the initializer portion of the constructor up here. If you're ever seeing yourself doing something that like member variable equals X, member variable equals Y, and it's just a pure assignment, it should be done in the initializer portion. You're right, and we do. So let's pop over to board for a moment then, I guess, because we need to create a board. And over here we have a board that takes in an int, the board size. It's going to be a square board. And then one thing that you're going to see me do that I didn't do before is explicit. This means I cannot convert an integer into a board. Which probably makes sense, right? Back down here with our complex number, notice that we have this one function that only accepts a real. And so what this function can also be used for is it can be used to cast a real into a complex number. So if I was doing something like this, like maybe like num4 dot add to self the value 5, that works. Or, you know, maybe like 5.5, that works. Because 5.5, is that a complex number? No. So what actually happens here when I do this call is we make a call to this constructor over here to convert that 5.5 into a complex number. So this function gets called, right? And we go and create it with the real value and then the value 0. And then that new complex number that we've created then gets actually passed to add to self. So it was able to cast this 5.5 into this double, right, into a complex number. I can also now do fun things like static cast into a complex number 35.78. This is now legal because I didn't mark it explicit. Now, if I come back here and I mark it explicit, explicit, this stuff back here is illegal because I'm not allowed to implicitly cast the 5.5 into a complex number. This guy over here should also be illegal too, I believe. But if I comment this out, no, he's still legal? I thought you'd be angry at me. I guess apparently that's still fine. But if you want the implicit casting, you have to leave off the explicit. So over here, it kind of makes sense to be able to implicitly cast a double, right, into a complex number. So we're going to leave it off. But back here in TicTacToe, it doesn't make sense to allow an integer to be turned into a board. Would you agree? Yeah, so we're not going to allow that. The other thing that we have to think about, we probably won't have a default constructor because there's no value that makes sense to be a default board for the general case. So we won't have a default constructor. This means we can't just say board anymore. Like I want a board B. That would be illegal because that would use the default constructor. So what are the member variables of a board going to be? How do you represent a board? What's it made up of? Right? It's like some two-dimensional structure, so we're going to need, right, we have rows of what? Rows of column. So we have rows of cells, you could say that, but a cell is simply a, well, maybe we have like rows of strings or something, right? Or rows of characters. We don't have tabs and new lines. Like there's a difference between what we have internally stored and what we decide to print to the screen. So two very, very different things, right? Because I probably don't want to store any like white space or anything additional over here. I just want to store like the X's and the O's. So what I might have is, yeah. Yes, but a matrix is a what? How would you define that? How would you do your matrix in Python? Oh, okay. So we need a two-dimensional structure. So how are we going to define that kind of thing on the board, right, as some type that we know of over here? Yeah. A vector of. A vector, say it again. Probably if you would do a vector of characters, or we could do a vector of strings. In Python, you probably couldn't get away with a list of strings very easily because strings are immutable in Python. But in C++, right, strings are mutable. So a vector of strings makes a lot of sense, right, for how we're going to represent this. This will allow us to do something like, you know, the board at ij to access some things. So we're going to include vector. And we are going to include string. And over here, we might have our std : vector of std : string And you might call this like, the board state. I don't know. Anything else that makes up the board? So the size we can compute, right? But we might want a method that's called getSize. And am I going to modify myself in this function? So what should I put at the end? Const. We also said that we needed one more other method, which was void display. Const. So let's go create the board. So one thing that we might want over here is there might be like one other thing that we want to have as a parameter. So you might have a character that we want to use to represent a blank spot, because it can be really hard sometimes to see like spaces on the screen. So we might have something else that shows up. And then so this guy over here also needs to accept one more parameter, which would be a char, blank char. And then back over here in board.cpp. So how can I initialize my board? Well, I got to initialize the board state, right, to be that size, and that board state needs to be full of blank characters, right? So I might say, like, I want a board state, right, that's board size big, and each of those elements needs to be a string, right? And that string, I believe we can do it as a board size blank character. Or did I get that wrong? I have to go look back at string to see if this works. And I will definitely explain the magic lines. But I gotta go look back at my constructors over here to see what's legal. It's size T, char C. Oh. I guess I have to do this. Is this you're complaining about? There we go. So if you remember, there is a constructor for the vector that takes in how many elements do you want, and then what value should each one of them be. So I said each one of these vectors should be made, I want board size vectors. Each one these elements should be initialized to a string that is board size big and filled with blank characters. Does that make sense? Yeah. So the board size, our boards are going to be square. So that's the number of rows or the number of columns, depending how you look at it. I'm pretty sure you want it to be something like, let's say we're using like stars for our blank character. We'd probably want something like star, star, star on each row, right? But if we just do it one character big, no space for the other two. And then the other thing that we need to initialize is the blank character, which is pretty simple. Blank character as blank character. And then we're done. We don't have anything to do in the body. And if you're doing your code correctly for this class, it'll be very, very rare for you to have anything in the body of your constructors. Yeah. So like if board size was 3, what would you get? You would get 3 vectors. Each of those vectors would contain a string, right? I guess just to say, you'll get 1 vector. That vector is going to contain 3 elements, which are strings. Each of those strings would be 3 long, and if the blank character was a star, they'd be filled with stars. So you'd end up with something like this right-hand side thing over here on the board. Right? Our vector contains 3 strings, string 0, string 1, string 2. Each of those strings contains 3 characters that are stars. One final thing, and then I'll let you go in a moment. For getting the size, that's pretty easy. We can just return board state dot size because it's square, and so I don't actually have to have an extra member, a member around to carry around my size because I can get it from my vectors. We will pick up with this on Friday. Hopefully, finish on Friday. Unlikely. If not, we'll continue it on into Monday. Yeah.
Okay. Well, first of all, do you know Qt by Nokia?
Say it again.
The Qt framework by Nokia? C++ thing?
No, I haven't
No?
used it before.
Okay. It was just an IDE that you could do drag and drop and you would do UI stuff and then code in C++.
Okay.
Anyway, the test case for the rock, paper, scissors that has a whole bunch of spaces. Do you remember
Spaces and tabs.
Spaces and tabs. So, do we consider spaces and tabs valid?
So if they did like space, space, tab, tab, rock, space, space, tab,
Yeah.
tab, it's okay.
That's okay.
So they can have, as long as they can have rock with like any amount of white space to the left or
Yeah.
the right of it, and it's fine.
Okay. Okay.
Yeah.
I was trying to train my total words, and I use a for loop at first, and then like I upload the cases, and it says like the same word needs to be on the same row, like they have the same times.
Mm-hmm.
But then I tried to enter a while loop inside it, that just seems not working.
So right now you have a map, right?
Yes.
And your map,
I actually put it back to a vector to sort it.
not necessarily. So your map right now, it's a map of